the other example that was in your booklet. Here we've got y is equal to 3x squared minus 6x plus 4. Let's go through it. So I should have done in the previous example, but I'm going to start by identifying what a, b, and c are equal to. So a is equal to, a is the coefficient of the x term. So here it's just at 3. B is the coefficient of the x term. So we've got a minus 6. And c is just a constant term. So I've got 4. Okay, let me go through the steps here. So the first step is I'm going to check the concavity. A is equal to what? A is equal to 3, which is greater than 0. So what do we know? This is a concave up graph. So it's going to be something like that. Okay, next part is my y-intercept. So I've got my y-intercept. So for y-intercept, I sub in x is equal to 0, or I just check the constant term. So here, my y-intercept is just going to be y is equal to 4, which is my value of c. Okay, step 3. I need to find my axis of symmetry. So for my axis of symmetry, just remember I substitute my b and a values into negative b over 2a. So I've got b is equal to negative 6, a is equal to 3. So I'm going to have negative 6 over 2 times 3. When I simplify this, this will end up just giving me 1. So I've got my axis of symmetry at x is equal to 1. Now that I've got that, what do I need to do? Well, I'm going to sub x is equal to 1 back into my quadratic function so I can find the y coordinate for my vertex. So here I'm just going to have y is equal to 3 times 1 squared minus 6 times 1 plus 4. Now when I do this, I think this ends up giving you 1. Let me just show. Yes, that is correct. So y is equal to 1. So I have my vertex at the x coordinate, which is the axis of symmetry, at 1, and the y coordinate 1. Okay, cool. That's the first 3 steps. Concavity, the y-intercept, and the axis of symmetry. Okay, the 4th step is I want to check my discriminant. So for my discriminant, if you don't want to write that much, like I did in the first example, you can just write the triangle and we're all good. And so here we need to substitute our a, b, and c values in. So I'm just going to write the equation for the discriminant. Get into the practice of writing the equation down if you know one. For your for whatever you're using, write it down first before you actually sub in the value. So I've got b squared minus 4ac. So I have my b value is negative 6. Negative 6 all squared minus 4 times a, I think, was 3, and c was equal to 4. Yep, so here we are. And so we've got 36 minus 48, which is minus 12. Now, once we found the discriminant, what do we need to do? Well, we need to just go, okay, is it greater than 0, less than 0, or equal to 0? Which one is it? This one is less than 0. So what can we say? How many real roots are we going to have? For this quadratic, we're going to have no real roots. So what this means is that our graph, our quadratic function, when we graph it, it's actually never going to touch the x-axis. It's never going to touch the x-axis. And so for that reason, I don't actually need to use the quadratic equation. In the previous example, we knew that there was 2 real roots, so we had to use the quadratic equation. But for this one, we can't. We can't do it. So what I'm going to do is, using all of this information I have here, I'm going to actually graph my parabola. Now, the only pieces of information that I know that I really have is that this, I've got the concavity, so it's concave up. I should have highlighted this from the previous one. I have my y-intercept at x is equal to 4. I have my vertex at 1, 1, and I know it's no real root, so it's never going to touch the x-axis. So here, for this example, I'm going to draw on. I'm going to move my, my y-axis a little bit to the left. So here we go. It's going to have it's concave up, so I'm going to go down. It's going to touch the y-axis at 4. Oh, I'm going to try that again. My arm bumped itself. That's a little bit better. So here, let's label on the information. I've got a y-intercept at 4. This is 4. I've got vertex at 1, 1. So here, down at the bottom, I'm just going to put 1, 1. So this vertex is 1, 1. I have no real root, so as you notice, it doesn't touch the x-axis. Now, when we're doing graphs like this, we need to also include one more other point just to ensure that we are showing the correct, this exact parabola, not any other one. So what I've done is I'm just going to pick any point. So I'm going to pick any x value. So let's pick x is equal to 2 and substitute that value into our quadratic. When I substitute x is equal to 2 back into our quadratic, I think it gets you 4. So I'm putting on another point here just to show that it's this specific quadratic. And so I'm going to have y is equal to 3x squared minus 6x plus 4. Okay. So this is how I do this second example here with using the quadratic equation. So when you're using the quadratic equation, what you want to do is you want to check the concavity and the y-intercept, the same usual first steps that we usually do. Then from there, use the area axis of symmetry equation, negative b over 2a. Find what the axis of symmetry is. Once you've done that, substitute it back into your original equation. Then once we've done that, check the discriminant. That will tell you how many roots your quadratic has. Once you've done that, if you need to, find what those x-intercepts are. If not, you know that it doesn't touch. If it has no real roots, then you're going to graph a quadratic function that looks something like this and doesn't actually touch the x-intercept. Have a go at a few of the questions by yourself. If you have any questions, feel free to post up on the Google Classroom.